Hey guys, welcome to my channel and I'm back again with another really interesting coding interview question video. In this video guys, we are going to solve question number 1984, the minimum difference between highest and lowest of k-scores. So without taking any time further, let's get started with the problem statement. So basically guys, we are given a zero index integer array called as nums. Here the nums I represents the score of the highest student. Along with that, we are also given an integer called as k. What we have to actually do is we have to pick the k scores of k students from the array, so that if you find out the minimum element in that k students, or if you find out the lowest element in that k students k scores, and find out the difference between the highest and the lowest, you have to provide the minimum possible difference out of all those k students randomly that you can select. Okay, let's understand it much better with an example. So first example is the base case guys, where the k is 1. So let's say it means that in only one student you have to find out the minimum score and the maximum score, and find out the difference and provide it to the as a result. Obviously guys, if there is only one single student that you can compare to, you can only compare the student to himself or herself, and that means if you do 90 is the highest and 90 is the lowest score, the difference is going to be 0, right? So let's say another example where k value is equals to 2. So let's say there are 6 ways to pick the scores of now 2 students. Now one way is that you pick 9 and 4, one is you pick 9 1, so on and so forth. And whenever you pick these two elements from this array, you find out which is the minimum element, which is the maximum element. You subtract the minimum from the maximum, you get a score. Now out of all these 6 scores, the minimum one I have to return. So that's why the answer is 2. Now this is the problem statement. Let's look at the constraints also guys. The constraint is that the length of the array goes from 1 to 1000 and the value of the numbers goes from 0 to 10 to the power 5. Okay. Now that we are sure about the problem statement, let's look at the solution approach in general. Okay. So first is the brute force approach guys. We are not going to implement it, but we will definitely discuss first about it. So first is the brute force approach. So brute force approach basically says you basically run a loop. So I0 to I less than, let's say, nums minus k, because at one time you are only going to select k element, right? And then I plus plus. Then once you are done with the outer loop, then you run an inner loop, right? So now you run an inner loop where your j value is equals to your I value, and it is going to be j less than I plus k. Okay, so for every single I, let's say for every single I, if I is 0, I will take the element from 0 until k. So I will pick 2 elements, right? And then in that inner loop I will find out the minimum element and I will find the maximum element in that inner loop, right? And finally when I am out of that inner loop, I will say maximum minus minimum, and that becomes my result. And obviously I want to return the minimum result, so I will return the minimal of the original result and minus the max min. Okay, or let's say we can say k min and k max, so that it is much more clear. Okay, so k min and k max are the minimum and the maximum element in that smaller sub array of k elements. Okay, and in this way guys, I will take this 9, I will go through a window of 0 to 4, I will find out which are the two highest and lowest element, and then I will put that into the result. Okay, now one important thing is guys, that this solution can still work for you, but the problem is that this array, if you look at it, if I move my k window from 0 to the next position, and then I move my second window from second position to the third position, this is not actually going to give me the correct answer, because the correct answer is 9 and 7, right? So the minimum difference is going to be with the difference between 9 and 7. So actually in one window 9 and 7 will never come together if I use this approach. Okay, so this is actually not going to work. What can actually work is that you have to again run some third loop which can actually for every single 9 find out all combinations of all combination of numbers it can add into that k window, and then you find out the minimum and maximum. Okay, so you basically have to add another loop here, another couple of complex logic to make this type of solution work. One more thing that you can do to actually make this solution workable is that you simply sort the array, right? So now let's scratch all this out and let's look into, if we sort this array, how we are going to easily solve that, right? So if we sort the nums array, let's say now my array becomes equals to 1, 4, 7 and 9. Now easily you can find out that the minimum difference contains two elements in our k array, and those two elements are 7 and 9. So automatically by sorting 7 and 9 are together. Okay, and also this is a good judgment, guys, because obviously if you have a sorted array, the difference between the consecutive elements is always going to be much more it's always going to be minimum, right? Whereas in case of a random array where you don't have surety that the difference between the consecutive elements is going to be minimum. So now once we have sorted this array, guys, it becomes much easier for us to actually implement a sliding window solution where we can just create a window of, let's say this is my window and it has a size of let's say 2, right? So this has a size of k, which is 2. I can easily take these two elements and move this window from first to second and then second to third and finally to the end to find out which are my minimum and maximum element. Now in the brute force solution where I was discussing, guys, we were also using a loop. So I was using a loop basically to actually find out the minimum and the maximum element in that k window. But because now this nums array is sorted, we don't even have to find out the we don't even have to find out the run a loop to find out the minimum and the maximum value. So in a k window, simply the minimum element in that k window is going to be nums, or let's say if it's a window, right? So let's say minimum element is going to be the first element of that window, and the maximum element is going to be the last element of that window, right? So we don't even have to run an extra loop to find out the minimum and maximum element. And that means, guys, with sorting, you can actually do this problem with just a single loop. Okay, so now we have gotten a little bit of idea of it. I am going to now write the pseudo code for this. Okay, the first line of the pseudo code is nothing but sorting the array, so that I have already written, guys. Okay, now the next part, as I told you, that we are going to initialize our result, right? So now my array is sorted. So the first window that I'm going to take is from 0 to k elements, right? So my initial result is going to be the kth element minus the first element, right? Because my nums array is sorted, kth element is going to be my largest element in the k window, and 0th element is going to be my smallest element in the first k window. And now I'm just going to keep moving my window, right? So for I in range, and by range I basically means we are going to start I from 0 until the length of elements minus k, because we are moving the k window, right? So we are going to start from 0 until the length of elements minus k, because at every ith position we are actually checking I until I plus k elements, right? So we need this. And next is that we have to find out the new k window, right? So the new k window is going to be the nums I plus k. Okay, so obviously guys, you are going to increase your window size. So at every ith iteration, I am going to add the I to my k, and then I am going to subtract the I from my I plus k, because now at every ith iteration, my largest element will becomes equals to I plus k, and my smallest element in the next window becomes my nums of I. Okay, if you interpret it just like this, you can see that the I value initializing going to be 0, and then 0 plus k becomes equals to k. But when I value will becomes equals to 1, the window will automatically move. Let's say from here it will move automatically to 4 and 1. Okay, cool. So now I have gotten my next result here. So what I can do is I can do result becomes equals to minimum of the original result and the new result, and finally I will return the result. Okay, so that was the pseudocode guys, and believe it or not, it is that small when I will start writing the actual Python code for it. So let's jump into the coding solution. Okay, so in Python we are going to do nums.sort. Now we are going to reduce the k value because k is 0, because our array is 0 index. So the k I have to reduce the value by 1 so that my k array also becomes 0 indexed. Okay, you can actually do first solution already earlier, that if so you can do already one solution earlier, that if k equals to 0, then simply, if k becomes equals to 0, then simply return 0. Okay, that becomes my base case, and now my initial result becomes equals to nums of k minus nums of 0, and for I in range, simply start from the length of nums minus k, because our window we are moving by k elements every single time. Result becomes equals to minimum of the original result, and this time we will add I to our k. So nums I plus k minus nums I. This is moving my window by ith iteration. Finally I will return the result. One thing I can do here guys, that this base case I can actually add before the sorting, because sorting is an expensive operation guys. So if you can avoid it by checking the base case first, then you won't need to sort it if your k is already 1, right? So I will just move the sorting after the base case checking. Finally I will do the rest. Okay, so now guys, let's run this code. Let's see if this works for our test cases. And there you go guys, it is accepted, and let's submit this code, and you can see it works clearly, submitted for all test cases. Now let's look at the time complexity. Time complexity guys is order of n log n, because we are using a sort operation, and then we have got a linear loop. Okay, what is the space complexity guys? So space complexity is going to be order of 1 in this case, because we have not used any extra space. We have just created a result variable, and that is it. So that's why there is no extra space consumed. So the space complexity is order of 1. Okay, so that was all for this video guys. I hope you guys liked the solution, and I hope it made your coding practice a little bit better. If you did like this solution guys, then please do not forget to like this video and share this video with your friend. If you have any questions, comments, suggestions, feedback for me, please do write down in the comment section below. I would be happy to address them. And in the end guys, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, and until then, take care and bye bye.